loops. We saw the for loop. We saw the while loop. We were able to use different arrays to loop over a sequence using the for loop. We also saw a countdown using the while loop. Today, we will continue with loops. We'll see what the repeat while loop looks like. We briefly saw it on Friday. We'll continue to see it today in an example. So, what are we talking about? We're talking about repeat while loop. So, repeat while. And for fellows from various programming backgrounds, as far as like programming languages, repeat while is the same as do while. So you may have seen do while before. Repeat while is the same, just renamed in Swift to repeat. Okay? What does that look like? Actually, let's review a little bit with the for loop. So if we have a for loop and say we want to go ahead and somebody asks us a question, hey, go ahead and print out 5 times the variable string, right? How would we do that? I'll give us 1 minute to do it ourselves, and then we'll go over it. So basically, the question is using the string variable print hello playground. Five times. Everybody got the question? Using the string variable above on line 9, go ahead and use a for loop to print out hello playground 5 times. Okay, Luba, please come up to complete the question. Okay, so the question asks, using a for loop, print out the string variable 5 times. So hello playground should get printed 5 times. So we start out with what? How do we start our for loop?
While.
How do we start our for loop?
For.
For, right? So we're using the for keyword.
String.
And now what do we need here? I'm sorry? Underscore if we're not using the variable name. Followed by?
In.
The in keyword, in some collection, in some sequence. Very good. Now we want to print it 5 times, correct? What sort of construct can we use to indicate 5 times?
Repeat.
A range, right? So what would the range look like? So Christian is saying 1.5. right? So how many times does that get printed? 5 times, right? So the 3 dots indicates what?
Range, open range.
Is it inclusive or exclusive?
Inclusive.
Right? So 1, 2, 3, 4, including 5, correct?
Mm-hmm.
Okay, go ahead. So we'll have open bracket, open curly. And now what are we doing?
Print.
And what are we printing?
String.
Straight. Excellent. Now go ahead and run it.
Where do I see?
Okay, there you go. So scroll up the console so you see more of it. Drag it up. Drag this up. There you go. Perfect. So we have 5 Hello Playground, correct? Thank you so much, Google. So this was a brief review of using the for loop, right? Here we're using the for loop. We ignored the variable name because we're not using the variable name here. Everybody with me? We're not using the variable name, so we ignored it. We used the underscore, and we said in 1 to 5, print string. So now that prints string hello playground 5 times. Every time it gets in here, it starts off with 1. It goes up to 2. Then 3, then 4, then 5. When it gets to 5, does it enter the for loop? When it gets to number 5, does it continue? In that case, it does, right? But when it gets to 6, does it continue? No. At that point, it's done. The condition has been met. No longer am I coming in here if the number is 6. In a loop, I iterate. Iterate means I go through the loop again until a condition is met and I'm done. Every time I iterate, I increment by 1. In that case, 1 gets incremented, it becomes 2. 2 gets incremented, it becomes 3, 4, 5, 6. It doesn't get into the for loop at 6. Was there a question? I'm sorry? So the underscore here, the basic syntax for a for loop is for keyword, some variable name here, you could put num. We agree we have a variable name called num, correct? And we have the in keyword, which is also required. And whatever collection we're going through, in that case, we have a range that we're going through. And we have our open curly, close curly, and whatever print statement we have. So far, so good? But we are not using num in the print statement. Do we see that? So if we're not using num, we have to use an underscore to ignore the variable name. So now the compiler is happy, the warning goes away, and we're good to go. Yes? Okay, an example where we would use num, for example, is here. So if I have for num in 1, I'll use the same basic example up top. Now, instead of saying print string, I'll just say print num. And num starts at what? Where does num start? Everybody? 1, right? Do we see that, Julia? So num starts at 1. Because how does it start at 1? 1 is the lower range of the lower bound of our range. It starts at 1, gets incremented every time it gets to the closed curly bracket. It gets incremented. It goes back to the for loop. It checks again. At 2, it's still good. It goes again. 3, 4, 5. 6, it does not come in because 6 is not between 1 and 5. Everybody sees that? So here on line 18, I could print num on line 18 and run it. And now we have 1, 2, 3, 4, 5. Everybody sees that? So in that use case, we would use the variable name because that's what we printed. Cool. So that is the for loop. Great. All right. So I will continue on to the repeat while here. Just grab my header. I'll copy the header, and I'll go down, continue repeat while. Okay. One of the fundamental use cases of the repeat while loop is if you have a scenario where you want some action to happen at least once. You want an action to happen at least once, you use the repeat while. Regardless of what it is, I want my code to run at least once. So then I use the repeat while. When it's run once, it checks the while condition to see if it's true. If it's true, it goes back and it runs the repeat block again. So if you want example for our text adventure application, we might want the user to see the game once, play the game once or whatever it is, take that action once, make that recipe, make that that bread, whatever we want to make in our text adventure, make it once, and then, hey, do you want to remake your bread, right? So at least once they're seeing how to make a bread or whatever it is, and at the end we have a while statement saying, do you want to continue? Yes, I want to continue. Everybody with me? As opposed to the while loop, where the while loop says, hey, regardless, check the condition first. Okay. Regardless, check the condition first before you go in the while loop. Okay? That's what the while loop says. Let's see what the while loop we had yesterday looked like. We had some variable seconds, and we had 30, and we said while seconds is more than or equal to 0, come inside of our while loop and print the seconds we have. Right? That's what we had yesterday. And what's the most important part of this while loop before we finish and run it? Right? Adam, right? So Adam is saying we need to decrement seconds. If we don't decrement seconds, what happens, Bienvenido? Right, so Bienvenido says if we do not decrement our 30 to get to 0, our while loop will be in an infinite loop. Right? An infinite loop means it will run forever until playground crashes. Everybody with me? Okay. So, Eric, you had a question? Okay. So here we will decrement our seconds by 1. And now we are good to go. But let's make this 10 instead of 30 so it's smaller. And we will play our playgrounds here. And we have 10, 9, 8, 7, all the way down to 0, and we are done. Everybody with me? Hello? Everybody with me? Okay, so this is the while loop. Again, it checks for the condition first before it enters the body. The body, when I talk about body, I'm talking about between the curly brackets there. It checks the condition of the while statement before it enters the body of the while. The body, the scope, right, the block, all those are valid here. So body, scope, block of the while, right? All refers to what's between the open curly bracket and the close curly bracket. Question? I saw a hand. Oh, that was a sweater. Yes, Christy. Chelsea.
So you said it checks the while seconds and then
it checks to see if seconds is greater than or equal to 0.
in the top.
In that part I highlighted here. So here, where I'm highlighting now, it checks that's a condition, correct? That evaluates to true or false, right? So it says, hey, is seconds greater than or equal to 0? Is it?
Yes.
Yes, so that's true, correct? So it only enters the body of the function, this here, the curly bracket, if this statement is true. That's the only time it will enter the while body, the while scope, the while block, if that condition is true. Everybody with me? If it's false, it will never enter the while. Okay? If I have negative 10 here, is negative 10 greater than or equal to 0? So we won't get our outcome if I run the program. My rocket is not going to go where I want it to go. Everybody with me? Okay, so let's go back here to 10. Yes?
So the very last part is what it tells it to do the next
This part here. This part here makes it stop at some point. Right? This part here decrements it, as we said yesterday. So decrements the seconds by 1. Right? What makes it go back? Nothing here makes it go back except the curly. When it gets to that end curly bracket, it goes back and check the while again. Right? That we don't have to write. That just happens automatically. Everybody with me? So it's like hitting a wall. It hits that wall, it bounces back, it checks the condition. Hits the wall, bounce back, checks the condition until it's false.
Is it acceptable to have two parameters? Like
You could have seconds greater than or equal to 0 and a different condition. As we saw earlier in the if else, you could compound them together. You could chain them together. Okay, so that's the while loop. Any other questions? Okay, so let's go to repeat while. So now we've seen what the for loop is. We've seen what the while loop is. Let's see what repeat while. And again, while checks the condition what? First, right? Okay, so repeat while. This one is going to get a bit more verbose here. So we'll start out by saying is playing. Have a variable called is playing. What data type is playing? What data type? It's a Boolean. Does everybody see that? This is type bool, right? Bool for short, Boolean. We'll have a current level. Of 1. We will have a final level of 10, right? Our game has 10 levels. So far, so good. And we are the current level, which is 1. We'll use the repeat while syntax here. So repeat while starts out with the keyword repeat, followed by an open curly. Press return, you'll get a closed curly bracket, right? Now it's still expecting more. It's expecting a while condition here. So while is playing equal to true. That's our condition. So imagine in this scenario, you repeat some sort of game, the player gets to see the game, and if they want to keep playing, it needs to be true. So they keep playing, it's true until it becomes false, right? In that case, it's not an exact infinite loop until when they say, hey, I'm done playing the game, I want to change it, it's false, the game ends. Let's see what that looks like. Okay, so repeat while, this is the syntax, the basic syntax. You have your keyword repeat, you have your open curly, your closed curly, and you have your while statement, which is also required. And now you could go inside and write your code. So code here. Okay. So we'll prompt the user for the current level they're playing. So playing level. We'll use string interpolation here to show the current level they're playing. And we'll use the variable current level to show that. So playing level, for example, 1. So the first time they come in, playing level 1. Everybody with me? String interpolation. So here, using string interpolation to show current level. Okay? If we get here and the current level equal to our final level, right? The player is about to finish the game, right? Do we all see that? If 10 equals to 10, I'm at level 10, right? I'm done, everybody? Okay, so if current level equal to final level, let's have a print statement saying, I will definitely recommend this game. And now the player is done playing the game. So what do we want to do to our is plain Boolean? What do we want to do? Right now the player is done playing. What do we want to do to our is plain Boolean in order for the while statement to be false? Make it false, right? Everybody with that? So now we want to change our is plain variable to false, right? So far so good. But it's already false. We'll change that later. I'll show you where we'll change it. Okay, cool. So far, so good. Okay, so is plain here. Okay. Go ahead and copy lines 37 through 33. Copy it. Or cut it, copy it. We need to refactor it a little bit here. So if is plain, we'll go over what that looks like. If is plain, we want to do the logic that we just did, right? So if is plain, I want to show the current level. If the current level equal to the final level, the player is done playing the game, and I change my is plain to false, right? Else, that means the player is coming here for the first time. So player is seeing our game for the first time, okay? I'll stop here so we could catch up with the code. So basically what we have, let me get some more space here. Can we all see everything, or should I scroll up more? Scroll up more, okay. So we have our repeat. We have our repeat while. This is the block for the repeat while. We just refactored the inner block of it to make it read easier. So if is plain, meaning if true, come in here and show the player's current level. And we also have an if block to say if the current level equal to the final level, then the player is done playing, and he says or she says, I will definitely recommend this game. And we stop the game by saying is plain is false. So this stops the game. And somebody was bringing up earlier, where do we set is true? We'll be setting is true in the else statement. When everybody's up to speed with the code. Okay, so I think we could almost get everything on screen here. A show of hands for who's still typing. Okay, so we'll give you guys a few minutes. Similar logic you could use for your text adventure using repeat while. Yes? The curly bracket above the else statement. This guy? This one? This one, so there's a nested if here. So there's an outside if, which is this one, and there's a nested if here that checks to see what the level, what the current level is. Cool? Okay.
It's two different.
If statements.
Okay, you have a repeat while, and then you have a if else.
So the repeat while is what we need for the repeat while loop.
Right.
Inside of the repeat, that's where you put your code, your logic, whatever logic you want. Inside there, what logic we have so far? If is plain, open curly, right? Mm-hmm. Else, we haven't written the code for that. And inside our if is plain block, we have a print statement to show the current level, and we have a check to see if the player has reached level 10. Teeny bit, it just says repeat here.
So an if doesn't always need an else.
What's that?
An if doesn't always need an else.
Yeah, exactly. As we said on Friday, an if doesn't always need an else. So that's where you will get in a bit with the inner one, right? Yeah. So an if doesn't always need an else. Yes. Exactly. Exactly. Good observation. So Eric was saying on line 35, it only gets inside 36 if 10 equals 10 here. Okay? So we need to increment our current level. Everybody okay here? Who's still typing? Okay, great. So now we need to increment because remember, if we don't increment, we're not going to get, the play is not going to move from the level that they're on. Everybody sees that? So we need to increment the current level. So let's go ahead and increment. So current level plus equal 1, right? Because every time you're playing, you want to get to a next level, correct? I mean, what's the point, right, of the game if you're not increasing your level? You got to get some feedback there. So current level plus equal 1 increments our current level. Our current level starts out at 1. Every time we enter that if block, it goes 1, 2, 3, 4 until it gets to 10. Everybody with me? When it gets to 10, it comes here, it checks, this is true. It comes inside this block here. It prints, I will definitely recommend this game. It changes the is playing variable to false. And when we check here, is playing is not true anymore. So the game is done. Everybody with me? Is playing, if I change is playing to false on line 37, when my check happens for the while statement, is playing will be false. So this no longer is true. So it doesn't go back to the repeat statement. At this point, the game is done. We'll go over it again. But let's finish the code here. Okay, so in the else statement, what are we doing here? In the else statement, this is the first time we're placing the game for the first time, right? So what we want to do is have a print statement saying trying out Pursuit Arcade for the first time. And here, now, we want to say is playing is true because the game started. The player started playing the game. Right? The player started playing the game. We have a print statement saying trying out Pursuit Arcade for the first time. We change our Boolean value to true. So now our while statement will be true. And the game continues. Yes. Let me slack it out so we're all on the same page here. So up to here, here. Okay. I know a lot of curly brackets. I'll slack it out for people missing curly brackets places. Okay, so okay, slacked it out. Questions? I heard I don't know what it's supposed to do. Question.
Can you like make it a little smaller so I can?
But the back, right? The back tends to not see when I go smaller.
No, not for now. Just for a second, just to see what the whole thing is supposed to look like.
1 second.
I feel like I have extra, like, I know you said the copy and paste, and I thought I copy and paste something and now it's smaller than what you have. So, what do you think? Right, so if we get this code,
Is that better?
yeah,
I know the back. I'm coming back. Sorry. We all should have the Slack code snippet. Yes, Shania. Yeah, yeah, definitely. So, okay, top down. We have 3 variables. We have an is playing variable. which is set to false. We have a current level, which is 1. You start a game, you don't start the game at level 10. You start a game at level 1. There's a final level that we'll get to, right? We're playing Candy Crush, we're trying to get to level 10. We're talking about repeat while. The syntax for repeat while starts out with the keyword repeat. Everybody with me? Okay, if I double click on the open curly bracket, we see the block, the entire block. When I say block, I'm talking about the body for the repeat. The entire body is where that beginning curly bracket is, and the closing curly bracket is on line 45. Do we all see that? Okay. Outside of the repeat brackets, we have while is plain equal true. Do we see that? We need that while. It's required. It's part of the repeat while. We can have repeat by itself. Everybody with me? So repeat while some condition. Some condition is whatever you have here needs to evaluate to true. Same as we saw with the repeat, same as we saw earlier with while statement, we have a condition saying is plain equal true. It evaluates to true, correct? Everybody with me?
Yeah.
Okay. Next up, we came in, we wrote some comments here on 31 and 32. 32, we said using string interpolation to show current level, which we are doing here. Actually, we are doing, let me copy this, and we are doing here. No, where is it? Okay, so we're doing some string interpolation where we're saying print, plain level, whatever the level is. Are we all on board with that one here? All, so far so good? So line 34 says print plain level 1, for example, or plain level 2. Everybody with that? Any questions? Any questions? Okay, so continuing, we have an if current level equal to final level. What is that looking for? It's looking for when the player gets to level 10. My current level is 1. Every time my repeat while runs, and it goes back to the beginning of the repeat while, I increment my current level. So if it starts at 1, how do I go? How do I count? 1 after 1 is 2, then 3, 4, 5, 6, until I get to 10. Everybody with me? Okay, when I get to 10, this condition becomes true. Yes? If that condition is true, I come inside my if block. What's highlighted now is my if block. In my if block, I have a print statement saying, I will definitely recommend this game. And then I change my is plain to false. Why do I do that? I want to stop the game. Everybody with me?
Okay. You put that on the standard bracket. Okay.
Right? So now I'm stopping the game, meaning on 37, I'm changing is plain from true to false. Everybody see that?
Yeah.
So now this happens, the current level gets incremented. I go to the while loop because no longer am I running the else. What do we say about if else? Either one of them runs, correct? Either the if runs or the else runs, not both. So this is just a bigger if, but we've seen if else. This is an if, this is 1. Either I go inside that if block or I go inside the else block. Everybody with me? Okay, so if I finish on line 39, do I go inside the else block? Do I go inside the else block? If line 39 gets executed, guys, do I go inside the else block here?
No, level.
I don't, correct? Because I've gone through the if already. So at this point, where do I go? I go to the while condition to see if it's true. At this point, is plain, what's the value of is plain? If I change the value of is plain on line 37, what is the value of is plain on line 45? False, right? So don't get misled by the 2 equal sign. 2 equal sign doesn't assign. It evaluates. Right? So this here assigns. Is plain gets assigned false. On line 45, is plain is an evaluation. It's a comparison. Is plain equal to true? Right now, it's false, so does false equal true? No, correct? So I'm done. Everybody with me? Again, a bit more code there, but that's what we have to get used to, right? Our if blocks are going to get bigger, more logic. Yes, Luba.
So
Line 32. Ah, thank you for bringing that up. As we showed yesterday from our example from the lab, is plain here, we could explicitly say equal true, right? This is also valid. But as Swift developers, we do not need to let the compiler know what we're looking for. This is kind of like redundant, right? Because here, is plain by itself says, am I true? So you don't have to explicitly say is plain equal true. If you're assigned to false, then this is false. It's assigned to false here. So the first time the game runs, what block gets run? Is it the if block or the else block? The else block, right? Everybody sees that? Julia says the else block gets run. The first time the application runs, is plain is false. So the if block does not get executed. Do we see that? Adam?
You're saying what happened is the one else and it will make the explain true.
Exactly. Exactly. So Adam is saying what happens in the else statement is right now we're forcing the game to be true. Right? The first time the player plays the game, it becomes true. That way the player could continue playing the game. Everybody with me? In your game, it could be up to you to ask the user, do you want to continue playing? But here, this is a simple illustration for how we could use repeat while. Everybody with me? Saren? Yes, question. Line 37. 39. What do you want? Line 34. Yeah, we could put it on line 34. You could put it here. 34 here. Yeah, you could do that. Because regardless, it's always going to run. Yeah. Cool. Any other questions? Eddie, how are we doing? Good? Julia? Oh. So Saren was saying put current level on 35, especially when we come to the case where this is true. If this is true, there's no reason to increment because we're done. So he was saying just move it up to line 35, right? That's more like a preference thing there. Yes? No, go ahead. Maybe it will help Julia clear up her question.
How can we assign something to be false?
Okay.
And then tell it your true. And then it goes back to being, and then within the loop it goes back to being false. Because at the end of the if, we're saying that.
At the end of the if.
Not the end.
The else.
The else.
Here.
At the end of the else, it's like, all right, if you can just say if true doesn't equal false, then go to the else.
In the else statement, this is the first thing that gets executed, right? Based on what we have currently, the logic. Everybody, do we agree the else statement gets executed first?
No, I don't agree.
You don't agree. Okay, that's fine. So, top down, let's go. I come into my repeat block. Everybody, yes? Is plain. What is plain value? False. Do I come inside the if block? No, I don't. Where do I go? To the else. What do I do in the else statement? Okay, and then what do I do on 43? Somebody else. What do I do on 43? Yes, George. Greg. I assign it to true, right? What happens next? What's the next statement? Why does it go back up, Zara? Because this is true. If it's true, it goes back up. Everybody? Right? We explicitly made it true here in order to keep playing the game. Okay? And Zara is saying, if it's true, it goes back to the repeat statement. You could explicitly make something true or false. It depends on the logic you're looking for. That's not a constant. That's not a constant. That's a variable.
It's a variable, okay. Because it won't say declaration.
No. They're all mutable here.
Okay.
They're all vars. We see that? So Tiffany thought it was a constant here. Everybody? It's not a constant, right? It's a mutable variable. Do we see that? Okay. Chelsea?
When I had final level as let, there was a message on my thing that said final level has been basically
Initialize.
Initialize, yeah, and you can't use it.
No. It was saying it hasn't been changed in the thing, so I changed it to let.
Oh, because you did not use it yet. You probably got a warning. You did get like a yellow thing, a yellow warning?
Yeah.
Yeah, because you wasn't using it. You wasn't using it yet.
But it's not.
It wasn't mutating.
Yeah.
Oh, I think I know what you're saying there. So, guys, Chelsea saw a warning on her terminal, on her playground. Final level, if you do not use a variable, the compiler will tell you, hey, you're not mutating this variable, so change it to a let. Our final level is not being mutated anywhere. Everybody with me? Right? So you could make final level a constant. Right? By making final level a constant, you tell the compiler this value is not changing. It's guaranteed not to change, so I'm marking it as a let. I'm marking it as a constant. So far, so good? Okay. Yes. I'm sorry, say that again. Oh, guys, sorry. Question. That's procedural, right? Top down, right? There's no function getting called, nothing like that. Everything happens top down. It reads top down. I have my variables declared. I go to my repeat. I go to line 32. I see what's happening there. If it's true, I go inside of my if block. If not, I go to my else block. Then I go to my while. I check my condition. If it's true, I go back to my repeat until it's false. Cool? All right. Yeah. Question?
Yeah, so I guess my question is, when does it, like, it knows that it's false once, current level equals final level, that's when it becomes false? Because as it goes through, it says, right, is true equal to false? No, it's not. So we'll go inside the if statement. It'll go down to the else statement. It'll say, well, it's true now. So while it's true, let's go back to the beginning, right?
Yes, as long as we're true, we want to keep playing the game, increment.
So as if it wipes it clean and it starts over as it increments. So as current level, so it only is when if current level. So that's what I'm saying. Like if it can't go into the if statement until
It goes inside the if statement. The minute
so
the,
but each time
the first time it gets to the else. After that, it goes to the if. Everybody sees that, right? So the first time it goes to the else, it changes the is plain to true.
Oh, and once it's changed to true at the end of the else statement, now it's true throughout.
Exactly, until it gets to level 10.
Until it gets to level 10, and once it's equal to level 10, then I will definitely, and then you make it false again. So if it tries to go through it, say that it's false and it'll go to the else.
And the game is done. No, when it's false, the game is done. Because now the while becomes false. Tiffany,
Oh,
you have to look at it, run it again.
I'm looking at it.
Yes.
Can you just show which curly brackets we have to watch the body of all
Okay, so the body of the repeat is the entire body until the while. So it's repeat while, right? The first if is lines 32 to 40, right, inside the curly bracket. Inside that has an if as well, which is checking to see if you're done playing the game, right? And then we have our else block outside. So far, so good? Oh, double click. So Yulia is asking how you see what scope of code you're looking at. You double click on the curly bracket, the open curly bracket, double click on the curly bracket, and it highlights whatever code that scope is. Everybody? Yes? No, ask the questions until you get clear.
All right, so after it goes to the else statement first, and then it'll say now it changes to true. So now if true is equal to true, then print the clear level is this level. Now if the current level is equal to the final level, print, I would definitely recommend this game. Now,
That only happens when 10 equals 10, right?
right. So now my thing too is that when it goes to here, like all right, well, it's plain, it's false. It changes it back to false so that it can continue.
If I'm false here, everybody, if I'm false here and I get to my while block, what happens? Do I continue the repeat?
No.
I don't, because it's false.
So that's what I'm saying. So it only goes false once current level is equal to final level. Other than that, it'll skip it. So if the current level is not equal to the final level, then it won't print and it won't return it to false. Basically.
Right, it will just increment and go to the next.
That's what I'm asking. So that's
Yeah.
why it's skipping things. That's why it seems like in my head I'm thinking like it's going through.
You only go inside the if it's true.
Okay.
Other than that, it goes back to the while.
So it was all right.
Cool?
Yeah.
Good, good, good. So whatever logic we have there, as I said, you could expand on that logic and create your text adventure game, right? You could have fun, you could do things. You could add everything we've been learning in here to make it more complex, depending on what you want. You could have switch statements. You could have for loops. You could have whatever that we've seen, you could add here to make your game really interactive. Cool. So that's the repeat while, and that's a good use case for the repeat while. You want something to happen once, and for example, if here in the else statement, we have a read line. Pay attention here, please. If we have a read line here, I'm not going to do that now. We can do read line in Playgrounds anyway. But if your user had a chance to say, hey, I do not want to keep playing that game. Everybody with me? On line 43, they would have a chance there to say, no, I don't want to keep playing. So at that point, it would only run once. Do we see that? Okay? But here, we have the use case where we're only saying, keep running until you finish playing the game. But in your game, you could prompt the user, do you want to continue, yes or no? Everybody with me? Okay, so that's on line 43. Here, you could prompt in a macOS command line app, you can prompt the user to continue or not. This would set is playing to true or false. Everybody sees that comment? Right? Do we understand that? What's happening there? So if you're in a command line application, a macOS command line application, I could have a read line there saying, hey, do you want to continue or not? Okay? Cool. If you have any other questions, please ask it. Don't feel we went over it enough before we move on. Okay, so we'll move on to nested loops, right? We'll see what nested loops looks like. Let me grab a header here. And we're looking at nested loops. Okay, so far we've seen loops, right? For example, we've seen for I in 1 to 5, right? We've seen this, print I. We've seen that before. We've seen it since yesterday, where we have one for loop. So far, so good? One for loop, it executes this 5 times, right? Do we agree that this for loop executes this for 5 times? Okay, so it executes 5 times. So far, so good. Okay, we saw nested if-else statements. Now we'll see a nested for loop. So here we'll have a next for loop with a different variable name going through the same sequence. Okay? And here, we will say what's happening in this nested for loop. Oh, sorry, yeah. Let me know when. Okay, cool. All right, so warnings everywhere because we're not using anything yet. But basically, what this for loop, the goal of that for loop is for multiplication table from 1 to 5. So the first for loop goes through 1 to 5, correct? What happens in a nested for loop we have to be very careful with. The first time it goes inside that for loop, the value is 1, right? The value is 1. So first time it enters the for loop, I is 1. That's very important. So the first time it comes in here, I is 1. So far, so good. Then it encounters another for loop. It encounters another for loop. And in that for loop, we have a print statement using some string interpolation. Once the warning goes away, the code will clear up. So we'll be able to see what's happening and be able to type. So we have a product happening here. Multiply I by j. So we're doing the multiplication table. So I times j is some value. I times j. Okay? All right, warnings are gone. Let's go through the code. I have two for loops. I have an outside for loop, which is this one here. So this one is outer for loop. Outer for loop. And here we have an inner for loop. And they both execute 5 times. Okay, so we agreed that the first time it enters the for loop, what's the value of I? I is 1, right? Because we started at 1, correct? We started at 1. The lower range of this range is 1. So I is 1 here. So what happens? It enters the second for loop. What's the value of I here? What's the value of I on line 56? Greg? 1, right? So it's still 1. It hasn't changed yet. Everybody? It's better to pay attention now to the screen. So now on 56, value of I is 1. What's value of j? 1. 1, right? So now we have 1 times 1. So far, so good? 1 times 1 is? So the 1 times 1 actually happens here in that string interpolation. The first string interpolation just displays the value. So what it looks like is, so we have 1 times 1 is 1. Right? So that's what happens. That's what the print statement does. I is 1, j is 1 is the value, is the result. So 1 times 1 is 1. We agree, correct? Or 1 times 1 equal 1, if we want that better here. So 1 times 1 equal 1, right? How we know from math. So we have the math multiplication table. 1 times 1 is 1. Now, the for loop has gotten to the end of the for loop. What does a for loop do when it gets to its end bracket? It goes back to check the condition again. In that case, it doesn't go back to the outside condition. It goes back to the inner condition because it's still talking about this for loop. We're still on the inner for loop. That's why it gets a bit confusing, especially the first time when you see a nested for loop. So the first time, this is I here. 1 times 1 is 1. Answer is 1. It goes back. It increments the 1. What's 1 now? 1 is 2, right? So 2 times what? 2 times 1, right? We see that? Right, sorry. Thank you. 1 times, no. Wait. So I'm still 1 here, 1 times 2, right? This is what we have here. So 1 times 2 is 2. What happens at the end of my for loop? What's I? I is 1. What's j? So 3. So far, so good? What's my next value? 1 times 4. And what's my next value? Right? So far, so good? So what's j right now?
5.
J is 5. Do I continue in that for loop? I don't continue, right? I go now to my outside for loop. Everybody with me? I go to the outside for loop. What's I? I is 2. Comes down here, does the same thing. I'm not going to type out the whole thing. But now 2 times 1, correct? Because our inside for loop always resets. Everybody with me? Our inside for loop always resets. So j is back at 1. So 2 times 1 is 2, etc. No, it doesn't stay at 5. It doesn't stay at 5. It resets again. Yeah. But the outside does not. Right? Everybody with me? Outside is the same. Inside changes. Outside changes. Inside. Outside stays the same. The outside loop here changes 1, 2, 3 until it gets to 5. The inner for loop resets. So every time I come back here, I start back at 1. Okay? So that's why my J here is 1. J is 1, J is 2. When J gets to 5, it gets outside the for loop. It goes to the next number, which is 3, and so forth. Whenever you get one of those problems in the beginning, please try to write it out before going to the computer to see what's happening. Questions? Now you can have more nested for loops here, but please don't do it. We'll talk about big O notation and complexity and runtimes when we get to Unit 2. But for now, know that nesting for loops, try to keep it at 2 levels, not 3, right? It becomes not as efficient. We'll get into it with big O notation. So that's nested for loops using a multiplication table. Yes?
Sorry, can you just explain how it will print? So it wouldn't print every single one. Does it print every single
It would print every single one until 5. So it would at 5 it would stop on 5 times 1, 5 up to 25. Right? So let's print it out to see what it looks like. We have a print statement. And after that, let's do the repeat while, because we never ran the repeat while, by the way. Nobody prompted me to do that. We wrote code, but we never ran it. You did. Good. It worked? Everything was great? Perfect. All right. So a mini's word. I take a mini's word here. Okay, so let's go ahead and run our for loop. Okay, I will pull that up. Let's see everything we have here. All right, so we have our multiplication table. Do we all see that in our console? 1 times 1, 2 times 1, 3 times 1, 4 times 1, and we end with 5 times 5. Why do we end with 5 times 5? Because our J ends on 5 here, okay? Our J ends on 5, our I ends on 5. So whenever you come across a nested for loop like that, you see what it goes over, and you multiply the two of them. This goes over 5 times. This goes over how many times? How many times does the inner for loop go? 5 times, right? So you take 5 times 5 is 25, right? So this gets executed 25 times. Everybody with me?
The inner loop is executed 25 times.
No. The outside loop gets executed 5 times. The inner loop gets executed 5 times. You multiply the two of them together, you get 25. Okay? I'll show you guys briefly, but again, we're not talking about big O right now. But for now, use the variable name n. Well, not n here, but let's have n here. Just say n to represent some sort of linear algorithm. It goes through 1 to 5 n times. Whatever n is, in that case, n is 5, right? So n equals 5. And over here on our inner for loop, n is also equal 5, right? So outer is n, which is 5. Inside is n, which is also 5. 5 times 5 is 25. So this gets executed 25 times, okay? And this is our multiplication table. Any questions?
So like the outer loop is the number.
You look at the number of times it's happening.
No, I mean like the outer loop is the number.
Yes, the first number. Yeah.
It's the multiple.
Yes, exactly. Very, very good. Excellent observation. So we have I and J here. So I is the outer, J is the inner. We multiply the two, we get a product. Cool? Chelsea? Good? That was A-okay? Okay, excellent. Let's move to the last topic of loops here. We'll talk about labels in loops. Okay. Labels in loops, they give us a way to go back to a certain loop, right? We could have, like we had earlier, we have an outer loop and we have an inner loop. We could give those loops labels. This is what we'll see here, how you could jump back to a different loop by its label name. So here we'll have some product that we're looking for. The product is 50. So the product is the value of two numbers. So here, product is the multiplication of two values, right? Example 4 times 5 is 20, right? So that's the product. That's what we're looking for. Whatever that adds up to 50, that's what we're looking for. So we'll start out by using a for loop here. So for I in 1 to 10. How are we doing? We good? For I 1 to 10. And we have an inner loop for j in 1 to 10. Okay? Here we say if I times j equal to the product that we're looking for, right? Print product was found by multiplying string interpolation by multiplying I times j. Okay? Exactly. So now we have our product. This is good. Else, we'll have some statement here. Print, keep searching. So far, so good. And here, if we do find the product, we want to break. In that case, we want to break to the outer loop. So how do we break to the outer loop when we're inside of a loop? This is where labels come in, right? So you want to break to an outer loop. In that example, you want to break to something. If you've seen functions before, think about it like a function where you want to go to a function. You want to call a specific block of code. In Swift, it gives us labels. So here we could give our loops label names. Any name you want. So in that case, we'll give our for loop here the name outer loop, which makes sense, right? And we will give our inner loop with colon, right? That's how you specify what the label looks like. And we want to break to the outer loop when we found the thing. It's not going to give you autocomplete. Hopefully, in some version of Xcode, that happens. So here we have two labels. We have two loops. We have an outer loop, which goes from I, 1 to 10. Bless you. And we have an inner loop, which we gave a label. So this is the label here. The name followed by a colon. That's the label name for the loop. And the inner loop, same thing. Whatever name we choose, followed by a colon, space, and then our for loop begins. So you could give inner loops, especially if you want to go back to the outer loop, you want to give it label names. So let's run the code and see what's happening, and then we'll go over it if you have any questions. So here, I'll run it. What I'm looking for? I'm looking for 50. Okay, so there we go. So it's searching, it's searching, it's searching, it's searching. It's probably good, maybe we put like what it's searching for. But it's searching, and when it found the first 50, it break out of the loop, and it went back to the outer loop. It's done. The program is done. We saw break yesterday. Break is I am done. I am done running. I'm not doing anything else. I'm done. Right? I'll show us again what continue looks like and see what happens to our code. Right now, it broke, right? It did not continue. It got out of the loop, stopped executing with the break keyword. Who's still typing? Okay, I'll give us some time to type, and then we'll change break to continue to see a different outcome. So let me scroll down, make sure we have everything here. Let me close this. So you see everything, and good. All right. And before I end, let's go back to the repeat while just to run it to make sure everything was good. Yes, Shania? Oh, okay. Cool. So we have labels in loops. The reason to show this example here, if you want to break out of an inner loop and you want to go to the outside loop, you use a label. The label is specified by some name that you give your loop, right? It's like giving a variable name. So we use the name outer loop because it makes sense here, but I could say top loop or bottom loop, whatever I want to. But here I said outer loop. That's the label name, followed by a colon, right? We have a nested for loop here, right? They're nested, very similar. This is very similar to what we did for the multiplication table, but the only difference is we're going from 1 to 10 here on both of them. We're looking for the number 50, right? The number 50 we find when we multiply I and j, two values together, to find 50. When we found 50, the first case of 50 we find here in the if block, right? If I times j, in that case, if 5 times 10 equals 50, it's true, correct? We come inside the if block, we print the product, what made the product. In that case, the product was made by 5 times 10, right? And we break, as we saw yesterday. We stop running. We break, and we return to the outer loop. The outer loop, in that case, is this for loop here, right? The for loop has nothing else in it, so it's done running. Is everybody done typing? I want to show what continue does. No, go ahead. It's not gonna, in that case, we're using break, it's not gonna continue. I'm sorry. I want to show you the difference, right? But the break does not continue. The break ends the inner loop. The inner loop doesn't search anymore. Tiffany?
So, okay, so I guess you tried to explain to me now to make it one more time, right? So, for mine, I put the code, but I didn't put outer loop, inner loop. I just put the code by itself, and so it prints it out 2 times. It prints it out that it found it at 5 times 10, and it picks out that 5.
Do you have a break?
At 10 times 5, and I do have a break, but I didn't.
You have to have a break to continue to the outer loop. If you don't continue to the outer loop, it just breaks and it finds a next case of the 50 for you.
Okay, so I have to break outer loop?
Break outer loop the way we have. To break to the outside. So when it gets to line 77, it goes back to line 73. And it doesn't look for any other values. Okay?
Oh, but in order for me to write that, I have to. Okay.
You have to put the label. Okay, so the next case, I'm sorry. Chelsea's question, how do we automatically indent again? So what you want to do, you want to Command A. So Command A selects all your code. And you want to Control I. So Command A to select all your code. Control I to indent. You're welcome. All right, so let's see what continue does. Yes, Mr. Matt.
Sorry, I'm a little confused. So when we're breaking to the outer loop, is the outer loop not just running again?
In that case, it's not going to run again to search for it, right? Because it's like, hey, I found the thing, don't run the inner loop anymore. If you want to run the inner loop again, you have to put continue. Okay? So if we put continue here, if we put continue here and we run again, so now we found 5 times 10 and 10 times 5, right? The first time it found it, it's no longer running the loop again. It's done, it broke, the application is done. If you want to find more instances of 50, you have to use the keyword continue. Okay? Those use cases come in handy when you have some sort of case like this where you want to find the first instance of something, break out of it, you're done. Okay? In that case, we want to find 50, the first instance of 50 we find, we get it, and we exit the application. So I'll go back to break here. And, okay. Any other questions? Yes, Stephen.
Yeah, but before when we did the break, but I didn't put the, or well, even if I would have removed the break by, oh shit, I'm sorry. But anyway, even when I removed the break, it did it twice without putting continue.
Even when you move the break here.
Like, even though the break was there, but if I didn't put break outer loop, if you remove outer loop, and it was just the break by itself, for me, it still came up, like it still gave me 2 times.
The only reason why we have outer loop, if we have more code to run, go back to the outer loop and run the rest of the code. Tiffany? You have outer loop if you want to have more code run in your outer loop. You say go back to the outer loop and continue whatever else you're running. For the outer loop, the reason why we have outer loop here, outer loop.
Now I'm saying that for it to print twice, when I didn't put outer loop and it was just break, it still gave me 2.
Okay, we'll take a look at it. What's happening on your end? Yes, sir.
So let's say I had a second inner loop.
A second inner loop where?
Um,
Oh, like a third one?
like within the outer loop, but not.
You could name it. You could also give it a name.
Yeah, I just hypothetically, let's say I had a second inner loop and then I broke out into the outer loop. I can never use this inner loop again, but when it run the other.
Let's see what you're talking about. So you have an inner loop here, right? So for k in 1 to whatever, 1 to 5, right? Print hello Matt, for example, right? Yes, so far so good? And then you want to give this one a label? We're not using K, so forget K here. What do you want to call it? Inner loop 2? Okay. And run it? Okay. No worries. I'm just waiting for you here. Okay. So there we go. So every time it comes in here, it prints hello Matt, because hello Matt there's no break in hello Matt, right? So it prints hello Matt 5 times in that case. 1, 2, 3, 4. The 5th time it didn't, because I think that's when it found the 5 times 50. You with me? It should have been 5 times, correct? How many times did we count? 1, 2, 3, 4. Right? It should have printed hello Matt 5 times. It printed 4 times. It broke out in the outer loop and it did not continue running. But if we do have continue, you'll see the 5th time. Okay? It's a bit complicated. Labels you won't use that much, but we use labels if we want to go back to an outer loop. We have loops of the same name. How do you go back? How do you go to the outer loop, right? You broke out, you want to go to the outer loop, you use a label. Okay? Any other questions before we continue? Tiff?
Well, basically, he explained it. So the reason why, because I put break on the inside, but I didn't put outer loop next to it. So it broke the inner loop. The outer loop is still going. So
Okay.
that's why the inner loop is still at 5 and the outer loop went to 10.
Got it. Okay, so again, programming has different constructs. Some of them you use more than others. This one, if you get to a use case where you want to go outside of a loop, you use it, right? You have 2 loops. You have a nested loop. How do I get to the outside loop? For example, I use a label. This is the use case there. Yes, sir? Else statement. This one? I just put a keep searching to show us some what's happening, but it's not exactly necessary. It was more about in the debug console. Sometimes you want to see the print statements, what's happening in your program. So that's why you do it. And sometimes, yeah, it's good for debugging as well. Yes?
I don't totally get how breaking into the outer loop is different from breaking into your loop.
Breaking in the outer loop. Breaking in the outer loop just says, I found what I'm looking for on line 76, break to the outside loop, continue wherever you are, and that's it.
So what is left to continue?
In that case, we don't have any code here, right? There's no code here. Let's put some code here. Will that help you if we put some code here? Okay, let's print done running out. Let's do that and see if that helps clarify anything. Clarification is key. Okay, so it did not even run that actually. Done running outer loop. Done running outer loop. Each time it runs it, and the last time it doesn't run it, it just breaks. Do you see that, Matt? So it ran, and the last time it did encounter the product, it broke out of the outer loop, and it's done. Okay? When break means exit, as we saw yesterday. Continue means keep searching to the next one. Break means slight difference between break and continue we saw yesterday. Break means terminate, end. Continue means go to the next value. Yes, sir.
So the last print statement is part of the outer loop.
The last print statement is part of the outer loop. Yeah. Okay. Yes, a mini, then you guys. Go ahead. Continue to the next value. Don't finish the wherever the continue is. Continue increment to the next value, but don't go further down. Eric.
Just to make sure I understand.
Yeah.
After you do break to the outer loop, the reason it's stopping is because it's ending on 10. Is that right?
It's 10 times 5.
But that means to stop.
Yeah, that means it stopped. It didn't continue. And then we showed continue would find the other value. Okay? Next question.
So can you execute the outer loop later in the program without running the code again?
Like a function, you mean?
Like just using the label as
No, it only needs to be within the nested loop. You can't use it outside. Like I can't go outside here and say outer loop. No, that would be a function. Yeah. So the good question by Kelby here. Can you access the outer loop outside of the loops? No. You have to use a function, which we'll see, I think, next week, where you could have your code in a function and call it wherever you want. Shania? The name is a way to access. Like, how do I access the kitchen? I access the kitchen because I know where to go. It has a name. If I don't have a name, I don't know where to go to. In that case, I said I found the product, break back to the beginning of my loop, my outer loop, and continue anything else you have. But in that case, I said break, so it's done. It doesn't continue. Okay? Next question. Yes, sir.
we're trying to get like print
Unterminated string literal. Your syntax, your quotes might be off. Maybe you missed a quote somewhere. One of us are going to walk around and see. It's more like a syntax issue there. Any other questions? We'll keep going through the use cases of inner loops and labels, but I want us to continue on to the strings lesson. So we'll come back and we'll go through what the question says. Okay?
Can we have a short 5-minute break?
That's where I was going, right? I know we all want to break, so I was trying to go to the break session there and come back and do strings and go back through labels as we need. Again, labels we don't use that much, but the labels, Stephanie, we use labels only when we want to navigate. We want to navigate outside of our inner loop, back to our outer loop. That's when we use labels. We can show loops without showing labels. Okay? Everybody with me? Because you'll come to a point, some use case where you're like, oh, I want to get back to the outside loop now. How do I do that? You cannot do it without using a label. Okay? It's a tag. Like I'm tagging my label with a name. I'm tagging my loop with a name. How do I get from my inner loop to my outside loop? I need to use this tag, this label.
Can you scroll up?
Scroll up. Okay, so any other questions? Chelsea.
So, the break, are you always going to be breaking the very first loop, or you can tell
It depends on what you're looking for. It depends on what you're looking for. You use break continue based on what you're looking for. If you're looking, like in our case yesterday, we were looking for Joshua, I think, or we were looking for something. You found it. You don't want to continue the loop. Get out. Stop the program. Okay.
But if you stop the outer loop, like everything's done.
That's it. It's done. Exactly.